Hello, my name is Bruce Slutsky. I'm a reference librarian here at the Robert Van Houten Library at NJIT. This is going to be a lecture on how to find physical and thermodynamic properties of chemical substances. It's primarily for students of Math 225, which is a statistics course for chemical engineering and chemistry majors, but certainly other students and anybody else interested is certainly welcome to see this presentation and see how the various tools that there are to find properties of substances through the traditional print resources and on internet resources as well. Okay, so that's the aim of this tutorial, is that there are many resources that can be used to find physical and thermodynamic properties of chemical substances, both electronic and in print, and we'll show you how to do that. Okay, so physical and thermodynamic property data are of value to chemists in academia and industry. So very often chemists will find a substance and need to identify it, and it's identified through the physical and thermodynamic properties. And then it's a match between what you found and what's in the literature. Okay, same thing, engineers need to use physical and thermodynamic properties such as heat capacity, enthalpy, density, viscosity, and so on in designing of processes. They need to substances which have certain properties. Okay, now physical properties, there are substances that are very well known, the household names, chemical elements everybody's heard of. There are also substances that are known to chemists but are likely not known to the lay public. But then there are also rare chemicals that maybe have only been reported in the literature once or twice. So that the more common a substance is, the easier it is to find the data that you're looking for. But also since there is so much redundancy in the literature, it's very possible that values may conflict. Okay, so there's a flow of scientific and technical information in all fields of endeavor, including chemistry. So we'll see a chart in a few seconds on how that information flows from somebody who is creating it to somebody who needs it at a point in the future. I discuss this in a little bit more detail when I teach Chem E 396, but I'll just mention it briefly here, showing this chart. So scientists and engineers publish in journals. Okay, it has to go through a rigorous, what's known as the peer review process before the information is actually in the published literature. But it's very often difficult to find data directly through journal articles. So there's a filtering down where over a period of years that information is extracted and placed into data compilations. And I think this lecture right now will be discussing the data compilations that you need to find the information that you're looking for. Okay, how many unique chemical substances are there in the literature? Okay, as of May 29th, 2014, there were over 88 million substances reported by Chemical Abstract Service. Of course, many of these are just academic curiosities. They may only be in the literature once. They're not of much interest. So people here at NJIT are more commonly looking for the data for more well-known substances. But if you're interested, go to www.cas.org and you'll see how many substances have been reported since late May of 2014, and it's growing by leaps and bounds. Okay, so let's see what a data compilation is. They can be in print or electronic format, and it extracts information from the journal literature so that you don't have to go to the original literature to find it. But again, there's no one universal data compilation. They're usually limited to a type of compound, such as organic or inorganic, or the type of property, thermodynamic, spectral, or physical. Okay, so there are many different types of data compilations. So a searcher may have to take some time and look at several data compilations to find the information that you need. For common substances, you may only need to look at one and you'll get the information you need. But for less well-known substances, you may have to search several before you find the information that you are looking for. Okay, so no single data compilation, of course, can have information on all the 88 million compounds that are known to man and have been reported in the literature. Okay, let's look at some of the characteristics of data compilations. Limited by the number of substances covered. Okay, that's needless to say. Limited by the type of compound. Some might be just volatile solvents. Others might be organic substances. Others inorganic substances. Selected properties only. Some may be limited to spectral properties. Others might be limited to thermodynamic. Available in electronic or print formats. Certainly print has been around for many years. Electronic is relatively new, maybe only 20 years or so have these data compilations been in electronic format. Some you'll see are in both. Okay, critically evaluated. Very often there's experimental error, and a good data compilation will have the data critically evaluated. So the experiment is repeated to verify that the data is correct. Okay, here are a couple of readings that I have on my page here, and even though one of them is from 1980, the other one is from 2001, the information in there is still very valid on how to find physical properties of chemical substances. Okay, here's some examples of some print data compilations that we have here in the NJIT library. The call number is where it's physically located in the library. So these are, even though they're a little old now, that the data in there is still valid. Okay, a couple more here on the next page. Certainly the chemical engineers who are seeing this are very familiar with the Perry's Chemical Engineer's Handbook. Okay, let's discuss now some of the electronic ones. I know in this day and age students are very reluctant to use print resources. Sometimes you have to, but I realize that, and I'll focus on the electronic resources that we have here at NJIT. Some of them are in the public domain. They're free to anybody. Some of them, like Scifinder, are subscription-based. Okay, so Scifinder is the electronic version of chemical abstracts from 1907 to the present. Contains links to full text of articles. You can search by chemical substance, reaction, research topic, author, or affiliation. When I teach in Chemie 396, I go into this in more detail. But as far as this lecture is concerned, I will only discuss how it's searched for chemical substances and how you can find some data. Okay, so there is physical property data available in Scifinder. Okay, so it's accessible now from a website. And let me discuss briefly what's meant by a registry number. The registry number is like the social security number of chemical substances. So very often a chemical substance will have many names. Could be like for a drug substance, it could be a proprietary name or a generic name or a name based on the chemical structure. And it may be difficult to search databases under the name of the substance. So that's why it's very often it's easy to search under a registry number. So they're unique identifiers for chemical elements, compounds, polymers, and so on. Okay, so we'll do a little exercise here using Scifinder. So it's to find the density of cyclohexanone at 20 degrees centigrade. So let's leave this PowerPoint for now. Okay, so to get at the databases from the NJIT library, we go into the library homepage, library.njit.edu. Click on the databases under S for Scifinder. Okay, so Scifinder is the only database that we have here at NJIT where you have to register and get an account. You only have to do that once, so I won't do that here. Just point over here if you need to register for an account at Scifinder. So I'll go in and I'll use my account. So you only have to do that once, and then you have use of Scifinder as long as you're at NJIT. Okay, so you see you can search different ways. I'm not going to search on a topic here. I'm going to go into substances and put under substance identifier. And I have here, I'll say cyclohexanone. Okay, search. Okay. So it gives you, here's the registry number for cyclohexanone, so you can search under that, the structure. But what we're looking for here is experimental properties. Okay, so we want the density. So here it gives you the density at different temperatures. So we have here the density at 20 degrees centigrade or Celsius, 0.945 grams per cubic centimeter. So again, if we go down the list here, it'll give you some of the physical properties. Certainly not all of them. Okay, but we were specifically looking for the density at 20 degrees. But there's other properties given here as well. Okay, so that's a very quick example of how to use Scifinder to find a physical property. We'll sign out of that. Okay. So hopefully you'll have some chances to use Scifinder while you are here at NJIT. Oh, nuts. Okay. Okay, now we're going to get into another database that we have here at NJIT. This is brand new. Okay, the database is called Novel. So it's a database of handbooks. Okay, so these handbooks have both textual information and property data as well. So it's a very useful tool. We've been wanting to get this here at NJIT for many years, and finally this semester we were able to get it. Okay, so again, there are 400 handbooks, over 400 handbooks in Novel where you can search. So example here, a few chemistry of the elements, distillation of vapor pressure measurements in petroleum products. Go to the next page, we'll have a few more examples. Hawley's Condensed Chemical Dictionary, Smithsonian Physical Tables. So we can search all over these 400 plus handbooks for both textual information and data. Okay, so there's an exercise here. Find the specific gravity of acetic acid. Okay, so what we'll do here, we go back to the NJIT library homepage. Okay, databases A to Z. We'll click on K and get Novel. Okay. Okay, so you want to do, this is for a textual search, and this is for a data search. So I'm going to say here, enter material substance name, and I'm going to say acetic acid. And once we put in acetic acid, this topic, it gives you the list of properties that are available in the Novel database. So what we want here is specific gravity. So we look down the list here, and here's specific gravity. So I'm going to drag and drop over here. Okay, there are 7 results, 7 sources within Novel which have that information. Okay, so we can have here, click on here, and see, it gives you different substances with acetic acid in there. So that's why it's always good to search under the registry number. Okay, so here's regular acetic acid, no modifiers. So this is the acetic acid that we want. And you see here it too has a CAS registry number, and the other substances which are not the same have different registry numbers. So we see here acetic acid, and we have here the specific gravity is 1.049. Okay, so we use Novel to find that. Okay, now we're going to go back. I think I have on my PowerPoint, I have another example here of find some basic information on carbon nanotubes. Okay, you can certainly find a book in the library on carbon nanotubes. You can find articles, but let's just show you how you can use Novel to find some information on carbon nanotubes. Okay, so go back to the database here. Go back home. Okay, we're not going to use data search, so we're going to say here carbon . Okay, so here are some examples here within the 400 handbooks that are covered by Novel. Look under here, and there's a little section here on carbon nanotubes. Okay. Okay, so it might not be everything that you want on it, but at least it's pretty much an introduction to it. So you can search for both textual information and data within Novel. Okay, let's move along now. There's a CRC Handbook of Chemistry and Physics. I think I've used that way back when I was in high school. But We have the print version at NJIT. Unfortunately, we don't have the electronic version. But as I mentioned before, there's a lot of redundancy. Then certainly you could probably also find the specific gravity of acetic acid in the CRC Handbook as well as a novel. So again, here's some of the physical properties that you can find in the CRC Handbook. Molecular weight, enthalpy of formation, boiling point, melting point, entropy, heat capacity, and so on. Okay, I obviously don't have the CRC Handbook in front of me, but what you can do, the same thing I found in Scifinder, see if you can find that value in the CRC Handbook and see if it matches. Ideally, it should match, that the values you find in one handbook are the same as in another one. But of course, there is experimental error, so you just very often can find discrepancies in the values. Okay, I have here a research guide on physical properties. So let's take a quick look at it now, but I'm certainly going to refer to it later. Okay, so we go back to here. So this is a list of data sources that I have here at NJIT. I really compiled this over many years. Certainly, as you know, as far as internet resources are concerned, can be here today and gone tomorrow. So this is a very long list of resources that I have here where you can search for data. Okay, I have a link to the readings here, a link to novel, and many other resources. And certainly within this lecture, I'm only going to discuss a few of them, but they're always here for you to review. Okay. So there's an index to physical and chemical properties. There's one from Arizona State University. So very often you'll have a physical property, but you don't know which one to consult. So this helps you save time. So let's say if you're looking for information on dielectric constants, what you would do is, okay, go back to my page here, and then here, guides for finding physical, chemical, and thermodynamic data, Arizona State University here. And you look under D, you look under dielectric constant, and it will give you sources, both print and electronic, that would have information on that. Okay, so some of these we may have here at NJIT, since it was compiled at Arizona State University. It would obviously include resources that they have, but not necessarily what we have here at NJIT. Okay, so that's a list of sources which have data on the dielectric constant. Okay, close that. Go back to our PowerPoint. Okay, Thermodex is something very similar that was created and maintained at the library at the University of Texas at Austin. And it contains records for printed and web-based compilations of thermochemical and thermophysical data. So you can select one or more compound types and link them to one or more property terms, and Thermodex will return a list of handbooks that might contain the data. So for example, you're looking for heat capacities of hydrocarbons. So what we'll do, it's over here, it's Thermodex. What was this here? Here it is, University of Texas at Austin. So I had here, what was that again? All right. Heat capacities of hydrocarbons. I'll click on the heat capacity here. Type of hydrocarbons over here. Search. And it gives you 18 sources where you could find heat capacities of hydrocarbons. Okay? Okay, these are obviously at the University of Texas. We may or may not have these at NJIT. What you would have to do is go into the NJIT catalog and look them up. Okay, so that's an example of using Thermodex. Okay. Okay, the NIST Chemistry Webbook. Okay, the NIST is a government agency. It's the National Institute of Standards and Technology, and they provide physical and thermodynamic properties of substances. Okay. Okay, so this is the type of data it has. Again, it's thousands of compounds out of the 88 million or so that exist. So it gives you enthalpy of formation, enthalpy of combustion, heat capacity, and so on. Okay. Some more data that it has there, infrared spectra, mass spectra, vibrational spectra, and so on. So let's do a search, gas phase thermodynamic data on bromoform. Okay, so we'll go to the NIST Chemistry Webbook. Okay. All right, so we'll go back to my page here and look under N for NIST Webbook. Okay. So click on here. Okay, name. We want to search bromoform. Gas phase thermodynamic data. Press here to search. And it gives you the data here. Okay, delta H of formation, heat of formation, for example. And it gives you the reference, okay, that when you look in a data compilation, it will give you the value. But very often that's all you need. But very often you want to repeat the experiment. You want to see the procedure that was done to get that information. So this was in a paper here, and it tells you what it was. So if you really wanted to see the information, the detailed experimental procedures, you'd have to go back to this original journal article. Okay? Okay. Okay, Chemspider. Chemspider is relatively new. It's free, you know, with the exception of Novel and Scifinder. Everything on that page is free. Anybody can use it. It's run by the Royal Society of Chemistry in the United Kingdom. You can search on, I think, a couple of million substances at least. So it says find the CAS registry number and density of ethylene glycol. Of course, there's more than one way to skin a cat. You can do it that way. You can use Chemspider. You can use other sources, but I just want to show how you can use Chemspider here. Okay, so I'm going to put in here simple search. You can search under the registry number, but I'm going to put under the name ethylene glycol. Okay, names and identifiers. So here's a registry number 107-21.1, and then I had wanted the was it the density that I was looking for? Let's go back, and density, yes. So looking for the density of ethylene glycol. So I look under here, properties, and gives you a melting point there, boiling point, flash point. Okay. Experimental gravity, the specific gravity is the same as the density, so that's what it is, 1.113 grams per milliliter. That's the density of, you know, ethylene glycol. Okay. Okay, material safety data sheets. Okay, that any organization, university, a company where there are chemicals in the workplace have to keep material safety data sheets for each substance that they have. They have them here at NJIT as well. So every company that manufactures a chemical has to publish a material safety data sheet. And now, of course, in this internet era, they put it up on the web for free. So here's a website here where you can find a directory of material safety data sheets. So they do have toxicological data, but they're also a very rich source of physical and thermodynamic properties of chemical substances. So that's one place you can go to look. Other sources of data. Now, there are many companies that sell chemicals. Sigma Aldrich is a very big company, and what they sell research quantities of chemicals. So what you can do, you can go to the Sigma Aldrich catalog and search for a certain substance that they sell, and they will list many of the physical properties. Okay, so some other sources that are good are Chemical Land 21, chemicalelements.com, and ChemBlink. Okay, now we're talking about our old friend, the Wikipedia. I think it's been around for about 10 years now. And students I know like it very much. It has its good points and its bad points. Obviously, anybody can put up information on the Wikipedia. You don't know how reliable it is. Somebody else could take that information, take it down, and change it, and it's wrong information. There is a lot of information on chemical substances in the Wikipedia, and I'm happy to say that there's actually a YouTube video about using the Wikipedia for a source of chemical information. And it seems that it's become very reliable in recent years. So I have a link to it. I think I have it on my page where you can look at that source. And in the past, I've given students an exercise. I use benzene, which of course is a very common substance. Find the density, melting point, boiling point, solubility of benzene in the Wikipedia, and then look for it in other sources, and they've seen that it matches. So I think you have my permission to use the Wikipedia to find physical property data. But again, it's not going to be exhaustive, so you may have to look at other sources. Mobile computing apps, okay? Many of the things that are on the regular World Wide Web are now on smartphones. Chemspider, there are a couple of resources for the periodic table of the elements. There's actually a listing of resources for the iPhone or iPad. So, people, I know everybody loves their smartphone, and please feel free to use it to find physical and chemical property data. Okay, so some summary of this little tutorial is that the reason we're doing it is that you're in the laboratory at NJIT and you're working with chemical substances, and you want to verify that the chemical substance you have is the one you think you have. The experiments that you're doing in the lab today were done many years ago, so that information has been documented in the literature. So you'll have to take the information that you find in the lab and compare it with the known sources in the literature. So as you advance your career here at NJIT, you'll get more adept at using the various resources that we offer you that are both free in the public domain and that we have to pay for. So again, that the original research which reports if somebody is making a chemical substance for the first time, it'll be in the journal literature. But as time goes on, it will eventually come in the data compilations. So it's certainly much more easier to find information in data compilations than it is through the original journal literature. Okay, there are 88 million chemical substances known. Obviously, the more common the substance is, the more easy it is to find the data on that substance. Okay, and again, it's possible for a common substance to find it in different sources, and the values may vary slightly. Okay, you may have to search several, if it's not a common substance, several sources to find the data you need. The material safety data sheets are another good source to find the data. There are indexes here from Arizona State, University of Texas, Vanderbilt. I think there were a few others on that page as well, where you can find an index. If you have a physical property, you don't know where to look, it'll help you. Okay, so that's my name here. My name is Bruce Slutsky. There's my email, my phone, and I'm certainly available to help you at any time in any of the courses you have here at NJIT. Just before I close, I'll just go back to my page here. So there are really many sources here, so you can browse through these. You're certainly welcome to use them to find the information that you want on chemical substances. So I hope you found this lecture to be useful to you. So thank you very much for your kind attention.